Hello everyone and welcome back to the course. So far we have looked at actors, their perception on the problem and their objectives. We have not yet discussed the problem field itself. This is a next important step in solving a complex problem, to make the problem field explicit. We start this by focusing on the criteria. In essence, the criteria represent everything that matters for the different actors involved in the problem. Therefore, things, whatever they are, that influence these criteria are of huge interest. Depending on your perception of the problem, you might consider the following mechanism for the Groningen gas case. The gas drillings in Groningen influence the amount of earthquakes, and earthquakes cause damage to houses, infrastructure, etc. The number of gas drillings in Groningen is dependent on the Dutch energy demand. However, if there are gas drillings in other gas fields, there are less drillings in Groningen needed. Also, the use of different energy resources, such as coal, also has an important impact on the amount of gas needed to supply the energy demand. How can these relations between different factors be displayed in a clear manner understandable for all actors involved? Analysts use a technique called causal diagramming. Here is how it works. The criteria resulting from the goal tree are good starting points for drawing up a causal diagram. Start by writing down a list of factors influencing these criteria. And the other way around, what factors will be influenced by these criteria? Do not forget to add reasonable units for each factor. You want to be able to measure the value of each factor numerically. If you find out that a factor does not have a unit, you should consider that factor a concept that needs to be operationalized further in subfactors. Things like the weather can't have a unit, however, it might be an important factor. So it gets operationalized in wind speed, rainfall, or average temperature. Also happiness or satisfaction, for example, do not have units either. Can you think of subfactors that can represent these and can be measured? The next step is to start linking the factors that influence each other. Label each arrow by a plus or a minus sign to indicate the relation between factors. When the arrow from A to B has a positive sign, this means that if the value of A increases numerically, the value of B also increases. This is a positive correlation. When there is a negative sign in the relationship, that indicates that if A increases, the value of B decreases. Each factor should be connected to at least one other factor. When a factor is not influenced by any other factor, it has no ingoing arrows. This is an external factor that cannot be influenced by actors in the system. It still is important though, as on its own, it can influence the criteria. So we should not forget it. When we discuss uncertainty in scenarios, we will learn how to deal with these external factors. All factors and relations should be self-explanatory as much as possible. A causal diagram is a model. It does not help to have a long text next to the model to explain it. However, relations that are not immediately obvious should be explained. If you have completed the factors in the causal diagram, have a look at your list of alternatives, your list of means, the ones that you have identified so far. All these means, all these alternatives, should somehow influence at least one of the factors in this causal diagram. If not, then the means are no good, as they cannot influence any criteria and thus cannot solve the problem. Or, of course, your causal diagram is not yet complete. The other way around, it's also possible to identify alternatives from your causal diagram. Imagine that the criteria represent everything that the actors involved in the problem field consider important. That means that anything influencing a factor in the causal diagram, and thus influencing the criteria, can be an alternative. Whether it will be a good alternative or not is for later. Now just try to identify as many alternatives as you can. To make the interpretation easier, different colors can be given to criteria, alternatives, and external factors. When interpreting the diagram, look for dynamic feedback mechanisms or feedback loops. When a causal path starts in some factor A and eventually joins that same factor A again, this is considered a feedback loop, as highlighted in the drawing. The type of feedback can be determined by counting the number of minus signs along the cyclic path. An even number indicates positive feedback, where an odd number indicates negative feedback. In a positive feedback loop, over time, the effects of changes or alterations may be amplified. With negative feedback, these effects might be reduced. Now let's move to Erik Pruit. He's an experienced system dynamics modeler. How does he see the relation between causal diagramming and his own practice?
We make simulation models that are fundamentally about causal relations. So each and any one of the relations in a simulation model is a causal relation, and the models are therefore causal hypotheses about how things work, how systems work. We basically use causal loop diagrams or causal relation diagrams in two particular moments during the modeling process. The first one is when we conceptualize a problem, so when we actually look at what the issue, what the system, what the problem actually is. And then we use that conceptual model to build a simulation model. And the second moment at which we use causal loop diagrams is when we communicate how behaviors are generated by particular structures in the simulation model. So that's basically to explain the link between the structure of a system and the behavior that we get from that. And that's very important since we actually change systems or try to change systems, the structure of systems, in order to generate better behaviors. Now, I can give you plenty of examples where we use this. What you see here is a causal model of a bank run, and here you see the behaviors of several of these causal models of particular types of bank runs that we simulate simultaneously. So this would, for instance, be the backbone of a stress tester for banks, where we would have causal models, that's the core, and then they would actually be so to say, attacked by all sorts of external events, and then we see how that system reacts in order to build a better internal model of a bank that we can use then to restructure a bank.
The second example will be based on Burgerz, a hamburger restaurant in Delft. Minke talks to Joey, the owner of the restaurant, about important factors influencing the success of her restaurant.
Hi, I'm Joey Perenboom. I'm the proud owner of Burgerz, where we sell great quality burgers. And today I've been invited to have a little sit down with Minke van der Klei, a student of your faculty, to sit down how we can combine your course with my restaurant.
Okay, this is a causal diagram. Did you see it earlier, or is the first time that you...
This is the first time, so you're gonna explain it to me.
Okay. Now, first I think you have income here. I think that's a very important point for us because it's a bit about the salary for me and to have a healthy business here.
Yeah.
So I thought maybe that's a good starting point, a factor that is very important for Burgerz. So maybe you feel a bit the same about that, or you?
Well, I think income, you need income because otherwise, we can't exist. But I think also, to be able to pay the staff and for you to be successful, for me to be successful, it's a result.
Yeah.
So, it's the basis.
The basis, yeah. So, and as you can see in this diagram, it's influenced by the turnover and the cost.
Yeah.
So, I think we look many times to the cost. So, how can we change the burger or make it a bit more simple? Mm-hmm. But otherwise, you don't want to change too much because it will influence the demand of the burgers. So, that's a sort of a trade-off because it can generate turnover when you make the price higher. Yeah. But on the other hand, you will lose the guests, and that's not what we want. So I think we have to look at the number of the guests. So that's important. How can we get more? Because that is important for us. Mm-hmm. And then you see on the left here the competition and the quality.
Okay.
And I think both are very important because both are factors that will influence the number of guests. Mm-hmm. But they're a bit strange, I think, because they're difficult to measure.
Yeah.
So I think competition, we don't.
Who do we have?
Yeah, McDonald's, Burger King.
Well, I think that's a bit like quality, isn't it? Like we try to be different, so our competition is maybe a little bit less because we keep the quality so high. Yeah. And then also the price of burger tells us that the quality is high. Yeah. But how do we, instead of making the burgers expensive, how do we tell people that the quality is good?
Yeah. Already. Yeah, I think it's not always very clear what we want and what the quality
yeah.
is. So do we explain enough that we have our own cows?
Yeah.
And when we serve the burger and the people eating the burger, have they the feeling that
they're eating a quality burger?
Yeah. Organic food is not enough for us, but we do a step more. So we have our own
further.
cows. Yeah, we go further, and not only in the quality of the burger, but also when you think about the service. So here when you come in and then you have people that say, "Hey, welcome."
It's not a snack bar.
It's a restaurant
that serves burgers.
Yeah.
Or presenting food as a burger.
Yeah. So it's a bit more than the competition in Delft.
Yeah.
And when you have a look about the income, of course we have to think about the cost.
Yeah.
Because otherwise, it will raise and more and more.
And the burgers will become more expensive.
Yes.
And the demand for burgers will be less.
Yes.
Which is
and that
not the result.
That's a very, very important thing to think about, because you don't want a very high price, because then people will come not in and they think
it's
too expensive for me.
a burger.
No, and we can eat for less by McDonald's.
Yeah.
But when they have the experience here, I think it's totally different what you can do, and
because the experience is part of the quality that we try to show people.
Yeah, so we have to think about the quality point.
Which we can do better.
Yeah.
Because we need to tell people.
Yeah, we have now the student burger on Thursdays. And I think that's a very good example of think about what your customer want or your guest.
The demand for
so we
the
make
products.
it easier for them to have a first time here.
Yeah.
And then they think, oh, nice, this is what we like.
Now I want to try the rest.
Yes.
Yeah.
So we have to think with other people how we can change it and how we can improve for them the experience of
and the whole quality.
Yeah.
Thank you for showing me this awesome little diagram. And now I understand that the income is of course for me a basis, but my core value is quality, and I think that's what we need to
I agree.
bring out and show people. And I'm sure you can help us with the whole showing people what quality is, and telling them in an image or in the menus, or get more demand for these burgers and get people in here.
Yes.
Now, let's move to your own case. First, study section 2.4 from your book. After that, create a proper causal diagram for your case. Start by identifying the factors that are relevant for the problem situation. List around 15 to 20 factors in a table and assign units to every factor. Show in your causal diagram how these factors are influenced to each other. Provide an explanation for causal loops in your diagram. Also provide an explanation for those relations between factors that are not immediately obvious. How are the main dilemmas in the problem statement of your actors reflected in your causal diagram? When making a causal diagram, there are few common pitfalls. Let's go over some of the most common ones. The first one is incorrectly formulated factors. Make sure that the factor you chose can be measured, have a unit, and are consistent with the actual problem situation. Otherwise, your causal diagram will have little use. This particularly means that all factors have to be defined very precisely. As soon as there is room for interpretation by using words like motivation, the weather, etc., the causal diagram loses function. There is no way that the factor, like the weather, increases. Maybe you need to use the factor amount of rain or wind speed. These two can increase, and even numerically. The second is incorrect explanation about the causality. For the problem owner, it might not be obvious whether there is a positive or a negative relation. He might not understand the idea of causality at all. Very often people explain the causality by saying, if factor A increases, then B increases too. Well, that is what causality means. However, it is not an explanation of that relation. An explanation requires that you explain why factor B increases when factor A increases. Go over your explanations and check. Good luck with your causal diagramming.